Welcome to video number 26. In this video, we're going to look at how do we approach designing a type hierarchy. So in videos 21 through 25, I just introduced you to the movement from C struct to C++ struct to C++ class. In C, you do a lot of modeling, intermediate models from the machine representation to some intermediate model that allows you to map a higher level problem, like a business problem, to this intermediate model. And you're always doing these mappings and conversions from the problem domain to the intermediate model to the machine representation underlying the intermediate model. So that would be a top-down. And a lot of times we work bottom-up from the machine storage model and processing model to some intermediate model and then map that to the problem space. That's very difficult to do. It's very unnatural. So C++ and other object-oriented languages that support type hierarchies are hoping and intending to move the designer closer to the problem space so they can think about the problem rather than thinking about the computer. So let's do a sample here, walkthrough. I've got a Word document open. Actually, it's on a Mac, so I'm using Pages, but you can do this on Windows using Word. And I want to call this Designing a Type Hierarchy. And so you can just open up your word processor and follow along. For my subtitle, I think I want to call it this. Okay, good so far. And I'd like to center both of those, so I'll center them. All right. And now I'll just say, okay, if we're going to create a type hierarchy, then we need a class that kind of describes the characteristics of motorized vehicles, cars, and the like. And so we did a little bit of this in class on Thursday. So cars, what does a car have that we need to kind of keep track of? What kind of characteristics? And so one thing we might track would be the manufacturer, right? Who's the manufacturer of this car? And what is the year of the car? And what is the model? Okay, so there's three good ones. I'll make cars a heading, and the stuff immediately under it, I'll make heading 2. All right, so then what else could I do? Let's see, if these are motorized vehicles, I guess we could make boats, right? So I'll do boats, and I know on boats, I'll make that, since that's going to turn into an object, I think, or a class. Let's see, boats, what do we want to keep track of? Well, funny thing, we're going to want to keep track of manufacturer and year and model. And so, okay, well, now we've got some duplication here. So let me make these heading 2. And let's see, what other things? Airplanes, okay? Airplanes. Well, now it's like, well, gee, don't we want to keep track of those things for airplanes too? You betcha. We do. Okay, so now there's all this duplication, and it seems like there's something deeper, something behind the cars, the boats, and the airplanes. And so I think what I'm going to do is I want to make a vehicle, I guess that's a good word, a vehicle class that has these shared characteristics. Since I see that cars, boats, and planes all have those shared characteristics, why not put it down there? Okay. All right. Well, that's great. So now we have vehicle and we have manufacturer, year, and model. And I still want to make cars, boats, and airplanes, and I still want to make reference to those. And so how would I do that? Well, I could inherit from. Cars inherit from vehicle. And boats inherit from vehicle. And airplanes inherit these properties from vehicle. So now it's like, oh, cool. Is there a way to do that in C++? And is this the right way to do this in C++? Well, we know this. We know that manufacturer, year, and model are shared across all three of these. And whether or not any of them belong at the vehicle level or the car or the boat or the airplane level, that remains to be seen. And that brings up a point that there's really kind of 5 stages of object design. And the first one is object discovery, and that's what we're going through now. We started with this idea of create a type hierarchy to model motorized vehicles that move people. And now we're kind of analyzing it. We're thinking through it going, gee, what do I need? Because we don't really know. And so we look to real world examples and we think about it and we discover that we have need for certain objects. And then we try and figure out how to assemble these objects. Where do the data members go? And where does the functionality go? Why? Well, I could include manufacturer, year, model in cars, boats, and airplanes, but now I'm creating all kinds of duplication. And if I could do it once and then have a higher order object like cars inherit all of the properties and behaviors of vehicle because they're common across all things, then I could also have boats inherit from that and airplanes inherit from that, maybe motorcycles, maybe submarines. I mean, so this is the idea of designing a type hierarchy. So this vehicle is called the base class. And now that we have a base class, we can say, I want to create a car class. But how, what kinds of things would we put under the car class? Well, doesn't every car have a vehicle ID number? And that uniquely identifies it. And I imagine boats do too. So you go do a little research and you find out that boats have a hull ID number. And then you're like, well, I imagine planes have the same thing too. And you research it and you find out that planes have a tail number. And these are different lengths. The VINs are like 17 characters all around the world. The HINs are like, I want to say they're 11 characters, but they actually might be a little different. In fact, the VINs might have a range as well. But the point is that a VIN is what you say about the ID number when you're talking about a car. And a HIN is what you say when you're talking about a boat, a hull ID number. And a tail number is what you're talking about when you're talking about a plane. So you see, as you diverge, as you start to specialize, then it makes sense that the VIN would be under the car object, and the HIN under the boat object, and the tail number under the airplane object. But they can all share all of the code and data members associated with storing who is the manufacturer, what is the year, what is the model. Now, at least that's what we know so far. So the 5 stages of object design, we just looked at 2 of them, is object discovery and object assembly. Then we're going to move to system construction, then to system extension, and then to object reuse. Now, I don't know how far we'll get, but at least we'll get through the first few as we go down this path of designing a type hierarchy. Okay, so now that we're this far, let's see what it looks like in the next video to turn this into some C++ classes, that base class, which would be vehicle, and cars, boats, and airplanes that will inherit from vehicle and automatically, just by inheriting, get all the functionality that we define in vehicle. All right, I'll see you in the next video.